Hey, what's up, guys? Welcome back to the Code Path to Pro. Today is Wednesday, January 24th. It is 9:05 a.m. Um, yeah, today, hope everybody's doing well. Hump day, middle of the week. Yeah, had an interview yesterday morning. Went okay. It was kind of just behavioral. But, I don't know, I guess I wasn't in a good headspace or something. Struggle with some of the kind of ramble on with some of the questions, but hopefully that goes through. And then update on I interviewed and did an assessment for this other place a couple weeks back, and just heard that they were suspending interviews for like final rounds, and until like next week or the week after, because they've been interviewing too many people and they have actual work to do. Definitely understandable. But yeah, hopefully I interview with them. Yeah, then yeah, so let's toss on some music and get the daily started. Um, I'm sad. I think I will do. I do have friends visiting this week, but they're not. They're not. It's like staying with me, so I think I'll be able to do one of the contests this weekend. Or maybe I think there's just one, right? Yeah, the weekly contest, 8:30 p.m. Yeah, I should be able to do that. Yeah, that'd be pretty sweet. Let's go ahead and register. Back end engineer. uh, yeah, do that, and then hopefully actually get Kaggle this weekend. Do some more Kaggle stuff. Be cool. Um, yeah, this problem super interesting. I gotta admit, I didn't. My roommate was doing this last night, and I was looking at it with him. So, I'm not just doing this off the beat. So I gotta say that. But it's a cool problem. It's pretty interesting. So we are given a binary tree where node values are digits from 1 to 9. Um, a path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. Return the number of pseudo-palindromic paths going from the root node to leaf nodes, right? Okay, so basically what pseudo-palindromic, what that means is, right, we're given a binary tree like this, and why is it? Oh, it's red because that's another path. Um, but basically, you can see if we're going down the binary tree, we go 2, 1, 1. That's not palindromic. You're like, what? What the heck? No, it's only pseudo-palindromic. So if we look at all the permutations of 2, 1, 1, right, our path, like 2, 1, 1 is a permutation, and then like 2, 1, 1, I guess, again, but the ones are flipped. I don't know if that counts. But then like 1, 2, 1. Oh, snap. That's a palindrome, right? And then like 1, 1, 2, just round it out. That's another. So there's, one of these in all the permutations of this path. There is one palindrome for sure, right? So we return 1 for that. Make you switch. And then the same thing here, 2, 3, 3. Yeah. And if you'll notice, right, right, so you might be thinking, okay, like, how should we approach this? We could do some form of graph traversal, or, tree traversal, like BFS or DFS. But then how would we keep track if something's palindromic, right? Well, one way to do that There's a few different ways to do that. My roommate actually used an array in a really smart way. I can show real quick, where he had an array of like length, I guess 9, right? Where you have like 0. I guess it's empty. It's filled with zeros. The array. Length 9. So 3, 4. Is that 9? 1, 2, 3, 4, 5, 6, 8, 9. Yeah. Right, so like indexed 3, 4, 5, 8. Right, so there's 9 spots. And basically he would, go through his path with his DFS, and using whatever the value at that node was, he would check off or check on, right, some spot in this array, right? So yeah, that's how he would do it. Another way you can do it is using a set, right? And basically how we do that is, right, it's not necessarily a palindrome. We can't necessarily check if something's like a direct palindrome, but we can check if there's a possibility, because that's all we have to do. We have to just check, it's pseudo palindromic. All we have to do is check if it's possible that there's a palindrome. So using a set, what we can do is like we would add. So we go through this pass. We add 2 to our set. Okay, boom. And we add 1. Okay, boom. And then we add another 1, and right, we can't also add that to the set. So what we do is we remove that from the set. We can just check, and that's the advantage of a set here, is it gives us O of 1 lookup time, right? Because it's like a hash set. My back's kind of sore. Right, so we hit the other one, we remove that, boom. So our set is just 2. And what we could do is check that, okay, basically something pseudo-palindromic. Our set's going to be, our pass is going to be pseudo-palindromic if and only if our set is less than, or this length of our set is less than or equal to 1, right? And why is that? Basically, there's 2 types of palindromes. There's palindromes like, that's not a good example. Palindromes like this, where we have even amounts of all numbers, right? And our set handles that by checking, by adding and then removing even amounts of numbers, right? Or we can have a palindrome like this, where we have even number of 1s, even number of 2s, and then we have 1 extra 3. So something could be pseudo-palindromic basically only if and only if there's an even amount of everything, and then there can only be one like odd number of one thing, right? Because if we had another, like let's say, okay, we have even numbers of this, and we also have a 4, right? So the count of 3 and 4 is also 1. That's not gonna work, right? That's not a palindrome. So yeah, this is really gonna test my DFS skills, but we'll give it a shot, right? Let's try. Something like this. You want another node rat. And curve set. After this, what are we going to return? Right, We will pass it a set. All right. Boom. Basically, what's our base case, right? Something like this, maybe. Not root dot right, not root dot left. So we just return. And then we check if root dot val. Else we add that. And then we also need to check if, right, like I was saying, less than equal to 1. Something like this. All right, let's take a look at what's going on here. So you can do this with bit manipulation. That's something I've noticed about the past few days of dailies, right? It's kind of cool, I guess. I don't know. I don't really want to do bit manipulation, right? But one-line solution. Maybe let's make just like this. Oh, here we go. return 0. This is the solution. Okay. So we just pass our set in here. I mean, we should be able to do it this way too. I'll just do it like this. So we have two base cases basically. We'll just make it more explicit. Probably going to return 0 otherwise. Cool. So it creates a new copy of the set. I'm up there. Good song. Yeah, this is a cool problem. Really cool problem. I mean, the solution is honestly amazing. Like, super dope. Let's see, Mikey. Yeah. Mikey's a beast, bro. Master student at Brown. Stud. They're putting their work in 2022, for real. Wow. That's insane. Oh, that's so crazy. Mikey, you're a beast. Yeah, this problem's super cool. And using a set to keep track of palindrome is pretty, or pseudo palindrome is pretty, it's really smart. Right, because we're not concerned about position. We're just concerned about counts. It's kind of similar to, I mean, not really, but, excuse me. It's kind of similar to, what are these problems? One of these problems, like these. Longest combinated subsequence and longest palindromic subsequence. Right, where you have to have, it's like a similar concept of palindromes where a palindrome can only have one odd character count in it. Everything else has to be even. Like every unique character in a palindrome has to have an even count to it, except you can have one, because right, that can be the center. Yeah. So basically, I think that, right, like using the set's really smart with this solution. And then the other thing that's really cool about the solution is this part, right? Because if I were to just pass in character set, right, which is what you might think of doing, we're going to get the wrong answer. Right? So look at that. Interesting. Like, what's going on, right? Basically, what this does is it creates a copy. Um, we can look it up. Say this using set on create a deep damn it. Using set a new set. So, yes, okay, I don't think they understood what we were saying. So, right, we're creating an independent copy, right? Done. When this goes passing set char set yeah. Oh, that's why it works. I'm gonna text my roommate. He's gonna like this. The uh, take a picture. So sets. Or oh. Mm. So cool. Oh, that's so cool. You guys see that? That's pretty cool. So basically, integers, I guess they're not primitive type. Are there primitive types in Python? I don't think, right? Oh, this is disgusting. Get out of here. This is it. Oh, okay. Okay, wait. So it's yeah, integer. So integer. Type. So above. Ah. Ah. Interesting. Huh. Okay. Cool. Good to know. Good to know. But basically, why that's important, right? Let's go through an example. Go right here. Right. I actually want to draw this out for myself too. So, all right. So right side doesn't really matter because we're not going to run into any interesting recursive calls with that. Right, because this isn't really, I guess there's some backtracking, but it isn't really, we're checking, because we're checking, we have to check root to leaf, right? We're not checking like part of a path or, whatever. So, it has to be a full path. But basically the interesting part comes when, all right, so this is our set. Let's say we go down the right, or the left first, right? So we have 2 in our set. Okay, fantastic. And then we encounter over here, we encounter the 3, fantastic. Then we hit here, we hit the other 3, we're like, oh shit, okay. So now we have, and what I'll do actually to really illustrate this is put our set here. Jesus, so bad. 2, right, that's our set there. Set here, at this level, on this side, is 2, 3. right? Our set at this level is 2, then we can count another 3, and we already have a 3 in our set, we count another 3, so that 3 gets canceled out, right here, or sorry, right here. We're removing, and basically, so now, and then we also were like, okay, we've hit the base case, not root dot right, not root dot left. We check, oh great, like this is a path, this is a positive path, so we return up our 1, our recursive call, right? Basically what happens is, after we check that this path exists, and we hit the base case, we're going to go up 1, right? And if we were just passing in our character set, our regular character set, what would be happening is this set right here would get passed down to here, right? So we would get like set 2, 1. All right, which, I mean, it doesn't matter too much in this example. And actually, if we did it this way where we went left and then right, it would actually work for this example, I think. But, in our case, we went right and then left. But anyways, right, this isn't a set either. But we didn't pass in the correct set to check this, right? Our actual set at this level and then going to here is 2, 3. So it should be, right, set equals 2, 3, 1. Uh-oh. It would if I this constructor of the DFS going. those sets. But the contains oh god. No, it's are sets immutable? They're not. They're immutable for sure. Gotta double check. Yeah. So I'm texting my roommate to figure this out. Alright, but yeah. I guess we can test that, right? I don't know. I don't know how he did the rest of his stuff. How he's doing his checking. And I want to get one more problem done. But yeah, this is pretty cool problem. Like really cool solution. And I definitely learned a lot just from this one problem, which is pretty awesome. It's a tree problem. It's a medium. It's TFS. Set. I'll give myself a yes for this. Oops. Right. Not necessarily. I mean, I didn't really. I kind of got like 2 reps in already on it, right? Because me and my roommate were talking about it a lot last night. Oops. So, yeah, it's a great help if you have somebody. I want to try one more thing with this problem, actually. I just thought of something. This is O n O n, right? Where our set could possibly, like, let's say, super unbalanced binary tree. You know, it's not saying it has to be balanced, so it could be a straight line. So we could store everything in our car set, the whole memory, and then we're gonna look at each thing once. So, yeah, we're gonna visit each node once. Is it O of N? I thought it's O of N. Yeah, should be O of N, yeah. And I'm curious. Wait, copy. Copy. I have to do copy. And this should fail. Ooh. Yeah, okay, good. This fails. No! It doesn't. What? Okay, now I'm confused. Why does this work? This work. Hmm. Damn it. Could we? This? Oh. Oh. So uh, oh. Oh. Okay. Dude, I'm officially really confused. Shotgun. Yeah. Hmm. So creating. Where. Changes to my list too. Or no. Mm. Hmm. Hmm. This is tricky, tricky. One more time. All right, well, that was I mean, this should also work if we do copy that. Deep copy, right? Now, if this doesn't work, I'm gonna be really like so confused. Okay, yeah, that works. Takes a lot longer though. But yeah, I think the preferred right here. It's fast. All right. Cool. Well, a nice. Let's go back up and finally. I keep skipping that problem. Clone graph. I hate that. I'll leave that for another couple weeks. I want to do like a nice, easy subtree. Okay, do this one. That we've done before, but failed. Bet. Alright, so base case. So here what we're doing, we're inverting a binary tree. I feel like this is low-key a famous problem. this is funny. This guy, I guess he's the guy who made Homebrew, was interviewing at Google. Or maybe he didn't, he was just commenting on it. Yeah, I don't know. Maybe this happened. But yeah, anyways. I guess it's the guy who created Homebrew. It's like a package management thing. I use it. I don't really understand fully what it is, but it's nice. It saves some sort of commands on the terminal. Um, but yeah, so we're given the root of a binary tree, invert the tree, and returns root. They took it out of the description. It's kind of sad. That's a really funny meme. Nice. You could shoot me, yeah. So anyways, given the root of a binary tree, invert the tree and return its root. So inversion, like, I don't know. For me, in my head, I think of it like, if the tree is like this, I think of it like flipping it upside down, but inverting the tree in this case means like right, left, flip. So basically what we're going to do, so if not root, we just return. Else, we have temp equals root dot right. Then we want to say root dot left equals root, and then sorry, I'm doing this wrong way. Root dot right. So we don't want to set that equal to temp. Yeah, root dot right equals root dot left. And then root dot left equals temp. I don't think that I need to return the root somewhere. Do you not want this else? do you want to sell? Solution. Do I need to put self here? Or do I just... Oh, okay. How can we return the root of this? We need this out of this. Okay. Do we need to define a VFS here? Let me just run it. Is this from? So we're flipping 7 to 2. Good. This goes left to right. It's not flipping 9 and 6. And this should work for these examples. To be able to print, but so root is 4. 1, 2, 7. Why does it not go 1, 3? Am I calling this wrong? I think I just have to do it like this. Yeah. Okay. We don't need all this. That was just to be able to make it so we can print. Cool. Nice. Yeah. So I just separate these out because you know we want to return the root. I don't know if I did that all the time. Yeah, if I can. Yeah, I mean, this is definitely a better solution. Since we don't have the extra function. Okay. But yeah, pretty similar. Pretty similar. Yeah, and I mean the time of this is O of n. Space is O of h. Yeah. Cool. We did it. Inverted. Yeah, I mean, just the other way to do this would be. Take out this. Shift tab is over. I think you just return it. On the cloud. Yes, I don't think we have to return them. Just go ahead and return. It's just using return. See what ChatGPT says. I didn't understand the question. Oh, yeah. Okay, cool. Yeah, I like that more. Just return. Just get rid of the none here. Sweet. Yeah, and where O of H in this case is the height of the tree, so it's really like log n. So I guess, yeah. But yeah, because that's the recursive stack. But it's better to use O of H because in the worst case, right, the height could be O of n. But yeah, cool. Thanks for watching, guys. Have a good rest of the week and day. See ya.